All right, so today we are taking a deep dive into the world of flowcharts and pseudocode.
Yes, exciting stuff.
And it looks like you've been doing your homework.
Definitely. We've got a ton of great material to work with for this deep dive. You sent us your notes, some slides, even a transcript from a YouTube video. Looks like Mr. Brown CS, right?
Yeah, he's great.
Yeah. So should we jump right in?
Let's do it. From what I'm seeing in your notes, it seems like both flowcharts and pseudocode are tools we can use to help us understand algorithms, but they do it in very different ways.
Absolutely. It's like one is a visual aid and the other is kind of like writing it out in plain English, wouldn't you say?
Yeah, exactly.
So you can think of a flowchart as a visual representation of an algorithm
Okay.
with different symbols representing each step and arrows to kind of guide the flow.
Right.
Pseudocode, on the other hand, is more like writing a set of instructions using plain language, just to make the logic clear without getting caught up in the specifics of any particular programming language.
Gotcha.
Does that make sense?
Yeah, it's starting to come together now. And thinking back to that Mr. Brown CS video, I remember him saying that an algorithm is really just a set of instructions for solving a problem.
Exactly.
And then a computer program is how we actually implement those instructions.
100%.
So it's like the algorithm is the recipe and the program is like the chef actually cooking the dish.
I like that analogy. That's a great way to think about it.
Yeah.
You've got your ingredients, which would be your data, and then you have your recipe, your algorithm, and the computer basically takes those and uses them to create the final dish, your solution.
Makes sense.
Flowcharts and pseudocode just help us kind of plan out that recipe, if you will, before we even step foot in the kitchen.
Yeah. So it's all about having a plan. I like it. Now, those flowcharts, when I was looking at your slides, I noticed all those different shapes and symbols. It's like its own language.
Yeah, it is. It's kind of like learning a new language. And just like any language, each symbol has a very specific meaning. Think of them like road signs on a road map.
Yeah.
So to start with, you've got ovals. Sometimes you see them as rounded rectangles.
Right.
And those typically represent the start or the end of our algorithm.
The beginning and the end.
Exactly. And then you've got parallelograms. And those typically represent input or output.
Okay.
So that's like getting information from a user, maybe some user input, or it could even be displaying results.
Okay, so those are important steps.
Very important. Now, rectangles are where the action happens. Those represent the actual processes, the instructions that are being carried out.
Okay.
And then we've got our diamonds. Those are crucial.
The diamonds. All right, I was wondering about those. What's their deal?
Those are our decision makers. They ask a yes or no question.
Okay. And
depending on the answer, the flowchart branches off in different directions.
I see. So they're kind of important for controlling the flow.
Exactly. And of course, you've got your arrows. Those are essential too. They show us the direction, the flow, and they connect all these symbols together in a logical sequence.
It's like those choose your own adventure books, but for algorithms.
Exactly. And speaking of controlling the flow, remember in Mr. Brown CS's video when he talked about those decision diamonds? And he said it's really important to keep them simple.
Yes, I remember that.
Like really clear yes or no questions.
Right. You've got to have those clear-cut options.
Exactly. Otherwise, it can get messy. So each decision point should really just create two distinct paths, just to make sure that the algorithm knows exactly what to do in every single scenario.
Gotcha. Yeah, you want to avoid those infinite loops if you can.
Exactly.
Okay, so it sounds like we've got flowcharts, which are all about those visuals. Then on the other hand, we've got pseudocode, which is about using plain language to outline the steps. It's like we're trying to write out how the algorithm thinks.
Precisely. We're breaking the problem down into those manageable chunks and just using these simple terms that anyone can understand.
Right. It's not about any specific programming language. It's just about the pure logic.
Exactly.
Now, your slides had some really good examples of pseudocode in action, and those really helped me understand the different parts that go into it. But maybe for our listeners who haven't seen your awesome slides, could you refresh our memory a little?
Yeah, definitely. Let's start with variables.
Okay, variables.
Variables, you can kind of think of them like containers for holding information, right?
Right.
So, for example, you might see something like x equal 5. X is our container, and we're putting the value 5 inside of it.
Gotcha. So X now represents 5.
Exactly. And that brings us to assignment. Basically, we use that equal sign to give a value to a variable, just like we did with xe5.
Right. It's like we're telling the computer, hey, remember this.
Precisely. Then you've got input-output. That's all about getting information from the user, like, hey, enter your age, and then displaying those results. So if you input 25, it might say, you are 25 years old.
So it's like a conversation with the program.
That's a great way to put it. It's that interaction between the user and the computer. And then we've got our Eiffels statements.
Okay, yeah, those always trip me up a bit. They seem kind of complicated.
They can seem a bit intimidating at first, but really they're just about decision making. Just like our diamond in the flowchart. It's basically saying, if a certain condition is true, then do this. Else, if it's not true, then do something else.
So it's all about those conditions and consequences. If this, then that.
Exactly. And of course, we can't forget our repetition. That's where loops come in.
Right, loops. Those are important.
They let us repeat a set of instructions multiple times, which is super useful for all sorts of tasks. And in your slides, I really like those examples you had for those, like how to figure out if a number is odd or even.
Yeah, or how to find the biggest number out of a bunch of numbers.
Exactly. It's really cool how pseudocode can break those tasks down into these really easy-to-follow steps, and it helps you focus on the logic behind it before you even have to worry about any specific programming language.
It's like creating a blueprint for the program.
Exactly.
Yeah.
A blueprint. That's a great way to think about it. And, the cool thing is, it's not just for computer science. I was looking at that Medium article that you sent over, and I was amazed at how flowcharts and pseudocode are being used in so many different fields.
Yeah, I know, right? It just shows how versatile they are.
Seriously, I had no idea.
Yeah, it seems like everyone's catching on to the power of these tools. So we've got these basic concepts now. Is there anything else that our listeners should keep in mind about pseudocode before we start getting into some more real-world examples?
Yeah, one thing to remember is that, unlike some programming languages, pseudocode doesn't really have a strict format. It's more about communicating the logic of an algorithm clearly, in a way that makes sense to a human.
Right, it's all about clarity.
Exactly. However, if you're taking an exam or something like that, it's always a good idea to double-check if the awarding organization have any specific format or maybe a reference language that they want you to use.
Good point. So it's all about being adaptable and understanding the core concepts rather than just memorizing a bunch of rules.
Exactly.
Okay, this is already making my brain do backflips, but in a good way. So I think I'm ready to see these concepts in action. What do you say we dive into some real-world examples and see how flowcharts and pseudocode actually come to life?
Let's do it. I think you'll be surprised at how often we actually use these tools without even realizing it.
All right, let's go. All right, let's get practical. Remember that website login example from Mr. Brown CS's video?
That's a classic.
It really brought the whole flowchart concept to life for me.
It's a process we do all the time without thinking about it.
Right. He started with that start oval, then went straight to a decision diamond. Do you have an account? If the answer is no, it whisks you off to a whole other flowchart, the sign-up screen, which is like a whole other adventure.
And that's where those subroutine symbols come in handy. It's like saying, hey, we've got a whole separate process for this, so let's keep it tidy.
Love that. Okay, so if the answer to do you have an account is yes, what's next?
Then it's time for some input.
Okay.
Parallelograms to represent entering your username and password.
Uh-huh.
Followed by a rectangle, because there's some serious behind-the-scenes action happening as the system checks if those details match.
And then another decision diamond, do the details match?
That's the moment of truth.
This is the moment of truth.
If it's a match, boom, success.
You're in.
But if not, that flowchart loops you right back to the beginning to re-enter your info. It's like a never-ending cycle of hope and potential typos.
It's so cool to see how flowcharts can show those different paths, those forks in the road based on decisions.
Yeah, like a visual choose-your-own-adventure for logic.
It's like a visual choose-your-own-adventure for logic.
Right, and that's the power of flowcharts. They make the logic of a process clear, whether you're a tech expert or just trying to navigate a website.
Speaking of logic, let's switch gears to pseudocode.
All right.
I loved those examples in your slides, especially the everyday ones.
Those are fun.
Like, who knew you could use pseudocode to decide what's for dinner?
It's all about breaking down decisions into those logical steps. Remember variables.
Oh, right. Those containers for information.
Exactly. Let's say it's pizza night. We can assign X to represent our hunger level on a scale of 1 to 10. So if by 8, meaning we're super hungry,
we order a large pizza.
Yeah.
But if X equals 8, maybe we go for a medium to avoid those leftovers haunting us later.
You've got it. And that's a simple example of how we can use pseudocode to represent decision-making in everyday life.
My mind is blown.
It's really pretty simple when you think about it.
So flowcharts for visualizing those steps and pseudocode for writing out the logic behind them.
Exactly.
I'm starting to see how these tools could be useful for so much more than just computer science.
Absolutely. Remember, it's all about breaking down complex tasks into smaller, more manageable steps. which is a skill that translates to all areas of life.
It's like having a secret weapon for organization and problem solving.
A secret weapon. I like it.
This deep dive has been a real eye-opener.
And we've only just begun to explore the possibilities. Flowcharts and pseudocode have applications in everything from business process management to education to personal productivity.
Okay, I'm officially hooked. Let's dive even deeper into these real-world applications and uncover more ways we can use these tools to our advantage. It's amazing how much we've covered.
Yeah.
We've delved into the basics of flowcharts and pseudocode, explored real-world examples, and even uncovered some potential pitfalls to watch out for.
Exactly.
I feel like I'm starting to see the possibilities in these tools.
And that's the key. Understanding the principles and applications of these tools is only the beginning.
Okay.
The real magic happens when you start incorporating them into your own thinking and problem-solving processes.
So, what's the best way to start putting these concepts into practice?
That's a great question.
Should I just pick up a piece of paper and start drawing flowcharts for everything?
That's a great way to get started.
Okay.
Think about tasks or processes you encounter in your daily life.
All right.
Maybe you could flowchart the process of ordering a coffee from your favorite local cafe or writing a blog post.
Interesting.
Or maybe you could create a pseudocode representation of your daily morning routine.
Those are great examples.
Yeah.
It's funny, I never really thought of those everyday things as algorithms before.
But they are.
Right.
They involve a series of steps, decisions, and conditions, just like any complex process.
Makes sense.
By trying to represent them using flowcharts or pseudocode, you'll start to internalize these concepts and develop your logical thinking skills.
It's like a mental workout.
Exactly. And it's a workout that can pay dividends in all areas of your life.
Right.
As you become more comfortable with these tools, you can start applying them to more complex problems and challenges.
You know, I'm starting to see how flowcharts and pseudocode could even be useful for creative endeavors, like writing or composing music.
Absolutely. They can help you break down creative processes into more manageable steps, allowing you to explore ideas more systematically and discover new possibilities.
It's like a roadmap for your imagination.
That's a great way to think about it.
This deep dive has been truly inspiring.
I'm glad you're finding it useful.
I feel like I'm not just learning new tools, but developing a whole new way of thinking about the world.
And that's the ultimate goal, to empower you with a more logical, efficient, and creative approach to problem solving.
Wow.
These tools are not just for computer programmers, they're for anyone who wants to unlock their full potential.
This deep dive has been incredibly insightful.
Yeah.
Flowcharts and pseudocode might seem like abstract concepts, but they're really just tools to help us think logically and solve problems in a systematic way.
And they're applicable to far more than just computer programming. Think about your daily life. Can you identify any processes or decisions that could be mapped out as a flowchart or written as pseudocode?
That's a great question to leave you with.
It's been a pleasure diving into these topics with you.
Thanks for joining us on this deep dive, and keep exploring the fascinating world of algorithms and logic.